Hello, everyone, and good morning, and welcome to my explanation of the Survivor Do or Die game. Now, this is an interesting dilemma because in the actual season, we've seen the player pick their box, and they stayed with their box, and they have won both times that they have played the game. And that is actually the incorrect method of going about the game, and the math proves it. So, basically, I'm in Python right now, and you have to import a random. This will basically let you randomize the selection of the three boxes that we're going to talk about later. And then a simulation count. So this will let you know that your math is accurate, right? When you repeat it a certain amount of times, just to let you know that your results are valid and they're not due to variance, right? So you have a game count variable. This is going to run through 1,000 times, right? Because this is linked through sim, and this is going to increase every single time the user runs through what we call this while loop. Now, we also have a player win variable. Now, variables are basically just names that can store values. So this game count basically equals 1, but we'll refer to it as game count. But the value inside that's stored inside that game count is 1, right? So this player win basically is the value of 0, and this player win is going to increase as we go throughout this if statement, which I'm going to explain later. But it'll go up, don't worry. So basically, while game count is less than sim, sim's 1,000 and game count's 1. So while game count is less than 1,000, this loop will run. So while the condition is met, the code inside it runs. When it's not met, it'll exit the loop. User selection, this is another variable, and it's going to equal a number between 1 and 3. Each of these numbers has a 33% chance, 33.33% chance of being selected, right? So user selection is going to be one of those three numbers. And prize is also going to be one of these three numbers, because that's how the game would work. One of your three boxes has the fire in it. One of them will keep you alive in this game, and the player gets to pick one of the three boxes as well, right? But if the user selection is not equal to prize, then you're going to win the game. Now let me explain this, right? So if you have three boxes and the player picks a box, let's say they pick box 1, the box on the left-hand side. The host knows which box has the fires. The host is going to remove one of the boxes from play, but the host has the knowledge that that box is incorrect. So that other box that is left still has the chance of basically what both of the boxes had before it, because the host isn't going to remove the correct box, right? So basically, if the player picks an incorrect box and they switch, then they are guaranteed to get the box with the prize. Because if they pick an incorrect box and they switch, they'll always win, because the host is going to remove the box that has the skull, the incorrect box. If you pick the correct box, you're guaranteed when you switch to get a skull, but the odds of picking a skull initially is 66%, and if you switch, you will get life. So that's basically the reasoning why if you switch, you'll win 66% of the time, right? So if your selection's not equal, you know you will win the game if you switch. So you're going to increase player win by 1, and then you're going to increase game count by 1. So now when game count is over 1,000, you're going to exit this while loop, and you're going to have a certain amount of player wins. And you're going to be able to divide the player win by 1,000, and the math says that you will win around 68% of the time. The math supports it. This is 1,000 simulations. I can make this 10,000, and it would actually be more accurate if it was 10,000. 66, 66, 66, So you see your variance just went down because you increased the amount of simulations that you ran. So that's what's so fascinating about the game of Do or Die, right? Is that the players made the wrong decision and they won twice. So can we see this move on in the future? Can we see players play the game suboptimally and win in the future? Let me know in the comments below. But that's all I have for this tutorial today, and I will catch you guys in the next one.